And
we're going to do some fun stuff here. So Joel says there's about 3 weeks of the solar energy that is available for photosynthesis. Now remember, there's only certain spectra of energy in the solar radiation that impacts solar energy, and that's mostly in the visible light range. So if you had to guess what percent of available solar energy for photosynthesis is being captured on this field in front of you, look about it, think about it a little bit, and then I'm going to ask for people to express their thoughts, their number. I don't want you to give a whole discourse on, canopy structure and leaves and all that. All I want is a number. What percent of solar energy are we effectively capturing? And I'm on this line because I'm actually kind of going to be looking both ways with mine. Has anybody said anything under 50%? No, nobody's been under 50%. We've been at 90 to 95%. Now, I'm going to tell you that there is no grassland community on the planet that's going to ever intercept more than 85 to 90% of available energy. It's just not in the structure of a grassland community to do that. I'm going to say the numbers that I came up with and allow you to be shocked and disbelieving and all that. So on the shorter side over here, I see about 28% solar interception. And on this side over here, I think we're 42, somewhere in that neighborhood. And I've come a long way. And so you have to, believe that I'm telling the truth, right? Now, what I'm going to put on as my qualifying factor is, for many years in our research, we actually measured solar energy capture. The instrument that we used to do that was a 1 meter long light meter. Every centimeter, so there's, in the course of the meter, there are 100, actually I think there were 99 of the sensors. No, there were 100. And it's a meter long, and you could put it at level position above the plant canopy, and it tells you how many lux of energy are at this point here. You could slide it in at ground level and measure the amount of lux captured there. And the difference between the two is the amount of solar energy that was being captured by the plant community. So the highest that any grassland community, and people all over the world have done, this type of research. It wasn't unique to us. We were just doing it in a particular location with different types of pasture. Nowhere in the world do solar energy interception in grassland communities exceed 85%. You get into very dense tropical rainforest, and it can get into the mid-90s. Most grassland communities in productive environments like this are going to max out somewhere between 70 and 80%. Now, if you look in front of you, does anybody see the soil surface? The soil surface. That could be bare dirt, or it could be that litter layer that is at the soil surface. Do you see that?
Yes.
Mm-hmm. If you can just stand here and casually see that, that tells you there's solar radiation hitting the ground. Mm-hmm. And then it becomes just a question of, you know, how much or how little is doing it. Almost all people grossly overestimate how effectively they're capturing solar energy. It's just, we do it because we want to feel good about our management and our operation. Now, if we went, and we may on the way back stop in something that's grown up much more than this. Like I said, just remember, we are 3 weeks into recovery. And what is your typical recovery length this time of year going to be? Well, you're stockpiling now.
We're stockpiling. Everything after about the August 9th is for stockpile.
So it's from August 9th to the end of the growing season.
That's right.
All right.
That's right.
So this is 21 days of recovery. If we had 70 days of recovery, and you know, if you look around, you might find an example of a place that didn't get grazed, you know, as severely as anything else out here, and say, oh, you see, I can, what did you say your number was?
70, 75.
All right, he said 70 to 75%. And looking right down in front of him at his square yard, you probably are at 65, maybe even 70 there. So you are actually probably pretty close to what's going on there. If the whole field was like this point here, we would be looking again at, you know, a 60-65% solar energy recovery, and without going to, you know, full rank maturity, that's about as high as you're going to get. These other ones, they are not where a lot of you, you know, would like to believe. Now, you can buy, I think for maybe $350 or something if you wanted to, a handheld photometer, I think they just call them photometers, that you can do, but it's just a single sensor that you can do that, measure it up here, measure it down there, and get an estimate of solar interception. Is it worth doing? I don't know. Depends on, I guess, your lifestyle and all that. You know. I'd pay $350 for a good bottle of scotch. So,
would you share it?
oh, of course I would.
Oh, good.
Yeah. The best thing to do, it isn't the precise number, you know, that's important there. It's just developing an awareness of what you really should be looking for. And it depends where in the stage of recovery we are at, what it's going to be like. Okay, so.
You want the ground completely shaded. In other words, ideally, you put the meter down low and measure zero.
You're never going to get, that's what I'm saying, you'll never get that in a grassland community.
That would be perfection.
Yeah, and nature has this beautiful rule, and it's one of the guidelines I live by. Never let perfection get in the way of good enough.
Mm-hmm.
All right. So if the inverse of looking at this is if you can look at the ground and you can, with just an honest, open mind, say, oh man, there's 20% bare ground showing. If you look down there and you see 20% bare ground showing, it's going to be really, really hard for you to have a pasture that's even getting to 45, 50% of solar energy efficiency. So we want to see the soil covered, but part of that cover is going to be the litter layer that we see there at the soil surface. Part of it's going to be green living plants. All right, there is a plant out here that is called horse nettle, and it is thorny and stickery. You don't want to grab that into your hand. So as a grazing animal, cattle, they tend to avoid those. At a real high stock density, they'll eat them. Goats will, eat them. Sheep, to an extent, will. The next thing that we're going to do is we're going to simulate grazing. And the average adult human's hand strength is comparable to the jaw strength of a cow. There's some people here whose hands are probably stronger than a cow. There might be someone like me whose hand is probably weaker than a cow's jaw. And that's just because, you know, I'm older than average. Now, if you watch how cattle graze, the way they are the most efficient in harvesting forage is if they're able to extend their tongue, pull in a wad of forage, and then shear it off. Remember, they do not have two sets of teeth. Sheep have two sets of teeth. Horses have two sets of teeth. Cattle do not. They have teeth and a dental pad. And so the way they harvest most efficiently is extend the tongue, sweep, pull a wad of forage to the mouth. So when we simulate grazing, we do not simulate grazing by reaching down and pulling up like that. We're going to enter from the side and we're going to harvest. So I want you, everybody's going to graze 10 bites, and I want that 10 bites to basically come off of a square foot. You retain the forage that you've grazed in your hand. That's your simulated rumen. And keep track of where your square foot is. And I gave fair warning about the horse metal, so don't anybody be, ow! I hurt myself. You didn't tell me about that.
Do we need to make noises too?
Well, you're welcome to. After you've done your grazing, stand up, hold in your forage. And there's a number of things here that we could talk about. And don't lose your forage, because we got to keep track of this. Yeah, well, he's gonna bill us for however many AUDs we've harvested. All right.
That's the picture right there. Look at the difference.
Exactly. So, isn't this simple? On average, everybody on this side of the circle has a smaller handful than everybody on that side of the circle. Everybody see that? That is simply the power of availability to intake. And I said on cool season forages, availability was more important than quality of the forage. On warm season pastures, it's a 50-50 mix. Is this a warm season pasture or a cool season pasture? What is this? Yellow foxtail is a warm season grass. What is this? It's either Dallas or one of the paspalums. That is a warm season grass. I saw some greasy grass in here also, which is a warm season grass. But we do have fescue, we do have bluegrass. This is a mixed pasture. This is the start of biodiversity that we would like to see, both warm season and cool season mix. And I would think that there's probably some crabgrass in here also, but I'm not necessarily seeing the crabgrass at the moment. But this is some diversity here. All right, so everybody has seen this yield difference. Availability drives intake. Here's where part of the problem comes. If you bring livestock back to a pasture too soon, and don't lose your grass yet, keep track of that, you get a smaller bite. We have not even looked yet to see if this one was grazing ready or not. That one looks like it is, but we haven't counted leaves on the tiller yet, which we were supposed to do that before we started this process, but I forgot. We will get it. All right. Now, look down into your square foot where you grazed. Are you capturing as much solar energy as you were before the grazing event?
Oh no.
You're seeing a little more ground being exposed, a lot less leaf surface. So, if we grazed to this point here, is everybody agreeable that we probably have reduced photosynthesis on this pasture?
Mm-hmm.
You bet, because we are intercepting a lower percentage of the available forage now. Please keep track of your first bite. Go back to that same square foot and take 10 more bites.
Go easy on Joel on this one.
I don't think I have 10 bites.
No, no, separate your bites.
And now, hopefully, you have first bite in one hand, second bite in the other. What do you see? Considerable difference? So most of you do in fact have a smaller second bite than first bite. All right, man, you're a lousy second bite grazer.
I was getting hungry.
Okay.
And I had to eat some horse nettle.
And he had to eat some horse nettle. So the amount of forage that was available to choose from declined because they took a big bite the first time. If we put this in the expression of days, you know, that's what they ate on the first day, that's what they ate on the second day. We could go back and do it again, but before we do that, again, keeping track of your forage, look down one more time. What's happened to your solar panel now? It's gone. It's much further reduced. So the percent of solar energy that we're capturing has gone down another increment. Let's think about, we'll think about a number of things. Let's start with the plant, and let's think about recovery. Would the pasture have recovered more quickly had we not taken that second bite?
Yeah.
Everybody sees that? Joel, do you recall what was the circumstance of why this, because this sure looks like this got grazed more severely than that did. What was the circumstance?
The circumstance was that I didn't give them quite enough here, and I gave them a little extra over here.
So you adjusted your allocation based on the results that you saw?
Adjusted the allocation. It was a little bit shy. And two, this over here is not quite as fertile as this. So you can't just go by land area.
Mm-hmm.
You got to think about, you know, what's the plants. This steep bank over here. Anyway, and it was extremely hot.
Mm-hmm.
And that's what these are shade mobile spots up here. But anyway, had a lot more steep bank. This gentle's out here, much more fertile. We run turkeys through here.
Okay.
So we had turkey litter on here, no turkey litter over here. So the fact is, I mean, the honest truth is, I probably shorted them 10% here and gave them 10% too much over here. That's probably the bottom line.
Yeah.
And I've been doing this all my life, but you do the best you can, and you still.
Exactly. You know, I often say, you know, I can screw up a pasture as bad as anybody on any given day.
Yeah.
I try to avoid doing that. But what Joel's talking about, again, comes back to this idea of being the difference between an A grazer and a C grazer. A C grazer would not have made that adjustment probably. May have noticed, well, we bit that one a little hard, but this looks a little better. We'll give them the same area because it's so easy to give them the same area every day. Because and the more uniformly shaped your fields are, the easier it is to always doing the same thing. When you have odd-shaped fields to begin with, if you don't leave these obvious lines, the odds that you will put a fence back in exactly the same place the next time is pretty low.
Right.
All right, so we're all agreed that the second bite has reduced the recovery ability of this pasture. Very good. All right, let's think about the livestock. If we are trying to get higher level of performance, which is more nutritious?
The first bite.
The first bite, because your highest energy level, your highest protein, highest bioavailable minerals, usually your vitamins, any enzymes there, the newest part of the plant growth is where all of those things are the highest. The older the plant growth, they're going to be lower. Nitrogen is a very easy example to use. In most environments, nitrogen is a limiting resource. So the plant, as it grows, maybe it's taken up all the nitrogen that was available in the soil. And so it has to start pulling nitrogen out of the bottom leaves, transferring it to the new growth. So you have a depletion of protein taking place as you go deeper into the canopy depth. All right. Did anybody notice any difference in the amount of energy it took to harvest the second bite compared to the first bite?
Yes.
Yeah. It was harder to pull. So this second bite is lower in energy and protein, lower in volume, and it was harder for the animal to harvest. That's what we call a lose-lose-lose situation. All right, we can turn loose of these now. Don't put them back on your harvested area, because we might want to do something else there. Now, as we look at that soil, or at that graze spot.
Now you're supposed to eat this and poop it out.
You know, we are just feeding.
Concentrated area. We have to break the circle because we don't want to concentrate it.
This is that one-day exception for education that we can screw anything up that we want. You know why?
That's right.
Because nature always bats last. She's going to forgive us for what we did here.
Absolutely.
It'll be all right. Now we're on a cloudy day. It's been a good growing season. This is pretty lush. And so the intensity at which we see sunlight hitting the soil and creating heat isn't that great at this moment. But if you visualize, a thinner pasture on a sunnier day, what's going to be happening to the soil where we grazed it the second bite?
It heats up.
It's going to be hotter, which means, and you do not have to have soil be 212 degrees Fahrenheit to have evaporative loss of water. There is a difference in evaporative loss of water between 70 degrees and 80 degrees, and between 80 and 90 and 90 and 120 and all that. Remember I talked about the snow disappearing off of our mountains due to vaporization, with the temperature never getting above 10 degrees Fahrenheit. Water vapor is constantly moving away from the earth. And, gas flow, water flow, hydraulic, whatever it is, the way all fluids move across a gradient. They move from an area of high concentration to low concentration. And if you have been getting regular rain, you have a dense plant canopy down here, well, the relative humidity in the bottom 2 inches of this canopy might well be 90+%. Might even measure at 100%. Up here, what's that humidity? Well, it's higher than it is in Idaho at this moment, I'll tell you. But maybe this is 75% humidity here. And if you have 100% humidity there, 75 here, there is going to be water vapor movement. It's always across that gradient. So you don't have to think about, well, the soil's getting above 100 degrees and I'm losing water. The difference between 70 degrees and certainly between 90 degrees is substantial and it's meaningful. We want to try to avoid that. So taking that second bite It was detrimental to plant recovery. That's a lose. It is detrimental to animal performance. That's a lose. And it's probably also being detrimental to soil water. And we haven't even started talking about the biological relationships. So most of the really beneficial soil-plant interactions are happening at soil temperatures from roughly 60 degrees to 80 degrees. That's the range where they're really optimized. When we get above 80 degrees soil temperature, we see some of these beneficial processes either slowing down or stopping. We go to 90, we go to 100 plus, and the biology is just fizzling as it gets hotter there. So keeping the soil is an important deal. Just for fun, guess what we're going to do?
Third bite.
Third bite off of here. And yes, it is very possible that you're going to start pulling up roots, because that's exactly what the animal's going to do when we push it to this situation. Okay, not a very big bite at all. A lot more soil exposure, a lot less leaf, and this is why absolutely this part of the plant belongs to the plant and to the soil. That you have no right to this. The animal better not be taking this, otherwise you're putting your property into that state of land degradation. And that's not a good place to be. Questions, comments, discussion on this part of it? No? Okay.